Good morning. Welcome to today's webinar. Today's topic will be on Chapter 9 of the FDOT SS3 Design and 3D Modeling course guide. And this chapter deals with the detail modeling tools, concepts, and also the data set that's in the course guide. And I'd like to go through a few things before we get into the session. What I put on this slide here were the type of things that you would normally want to detail out in your corridor or in your project design. And these are some things that are easier to do in SS3 than they were in the SS2 Roadway Designer tools. They kind of combine some of the Geopack site tools and the corridor tools all in one. And so things, what we're going to be focusing on this morning is basically building an intersection. But I can, if time permits, I can also show you how you could do traffic separator noses, turning islands. We can talk about driveways and sidewalks. We've also modeled this way for curb transitions, roundabouts, mitered intersections, slope transitions, anything that is not typically easy to model with a normal corridor design and a template. We still will use templates, we'll just be using them in a little different fashion. So the main point of this slide is that you know, while you're developing your projects in SS3, I would do a little planning ahead, which kind of leads me into this next slide. And that is that you got to kind of decide before you get into the whole corridor design about what you plan to use for the corridor and what you plan to use for the detail modeling, because the techniques are a little different, and I'll show you in this project a good example of how that would be. As far as doing the detail modeling, you're going to be working with linear templates, building terrains and surface templates, and then you'll be integrating them with the corridor by using a corridor clipping technique. And then also sort of an advanced concept that we've already scheduled another webinar, and that is leveraging 3D civil cells. And a 3D civil cell would really just be a sort of a detail model of a specific you know, a specific circumstance, like a driveway or a traffic separator nose. And once you've built them and you've tested them on one corridor, you can save them in a civil cell library and then apply them on your next project, or even within a project. If you build it once in one project, or in this one project, and it gets replicated, then just go ahead and apply it that way. That's a little more advanced, a little more difficult to set up and get working, but we can at least talk about that technology in the next, in the advanced session to this detail modeling. Now, a couple of the other things about planning ahead is in your corridor, you're typically, as you go across intersections, or maybe even where you want to have a different type of end condition, you might want to put in driveways, or let's say it's a retaining wall, or got to be a pond and you want it to slope it a little differently. You could actually create end condition, what I call end condition gaps in your corridor. And you can do that by triggers, switches, or even end condition exceptions. And I'll kind of talk about that a little bit in the live session. And the reason for that is it will make basically your processing a little more efficient. If you just blast your normal end conditions through an intersection and then come back and design an intersection, you're going to end up using corridor clipping, which adds a little overhead. Every time something changes on your corridor, it's going to go back and have to reclip it again. But if you use these, what I call gaps, or you kind of plan in gaps on your corridor where you don't actually add in the curb and the sidewalk, the buffer, and all the end condition slopes through an intersection, then when the corridor reprocesses, you won't have to worry about all the clipping. But it is optional. I mean, the software works either way. So then I'm going to talk about the general workflow steps for creating detail modeling, and it's simply these 5 things here. First of all, you're going to build 3D lines off of your 2D lines and profiles. And we're going to go through several exercises of doing this, but this is really the whole key concept of this whole detail modeling, is that what you're trying to do is build a terrain from elements, and the way you can get the elements is to make them 3D elements off of your 2D plans by putting profiles on them. And we'll talk about how you get profiles on your 2D elements. There's several different ways. Once you have that terrain, you can add break lines to it if you need to make it slope a little differently. But basically, once you have it, then you apply what's called a surface template, which is nothing more than depth to, it's a depth component to your terrain. And then it becomes like a thickness of pavement or a thickness of pavement and base for the boundary of your intersection pavement, for example. And then once you have that, then you can go back and apply a linear template, which might only be a curb and a buffer and a sidewalk, and then the 2 slope lines, a buffer off the back of sidewalk, and apply it to touch the target surface, your active terrain, and it finishes out the intersection that way. And then once you have that, there may be clipping references between corridors as necessary, and that kind of reflects back to the previous slide. If you've not clipped out or planned for corridor gaps, then you might need to use clipping references to clip those out. So those are basically the steps, and the chapter really, it basically starts with the first planning steps as far as building some gaps in your corridor so that you can plan for the intersection. And then we go through the process of building 3D lines, creating a terrain, applying a surface, applying a linear template, and then clipping the references. And that's the whole sort of chapter 9 in a nutshell. Now, some of the things I want to talk about here as far as the tools are these specific tools. These are the tools that you'll be using over and over to create the profiles from your 2D lines. One is profile by 3D element, and I'll just give a little description. Essentially, the way that works is you identify a plan element that doesn't have a profile, and then you can go select an element on your corridor. Let's say it's an edge pavement line, and it will actually project that profile to the 2D element. Okay, and that is something you gotta, it takes a while to get in your brain, so to speak, is because if you think about it, our corridor is based off of a plan, and our plan has edge of pavements. But as soon as we apply a template to that corridor and then assign those corridor references to look for edge of pavement, it's really creating 3D elements separate from the 2D elements. Okay, now the 2D elements don't have any profile. The 3D elements are what we're going to use to put the profiles back on the 2D lines. It's circular, but once you've done it a few times, it's pretty straightforward. Another tool that we use, especially around curb returns, or curve returns, if you want to say it that way, is this quick profile transition. If you've created a fillet or a radius off of 2 lines, and it is trimmed back to both, and each of those original lines had profiles on them, you can use this quick profile transition tool, and it will place either a parabolic curve between the 2 tangent lines or even a reverse curve. I'm going to show you that a little bit this morning as well. Profile intersection point, what that does is it lets you plot a crossing profile on, or a crossing elements profile on the profile of the element that you're looking at. And that I can show you that as well. That's really handy. Quick profile from surface basically is like a drape tool where you've got a 2D element and you want to drape it to your proposed surface to see what the what the profile would look like if it went across that surface. Same as like a ground profile, except in this case you're doing it from the proposed surface. And then profile complex by elements is just whenever you've got a bunch of constructed elements in your profile view and you want to complex those together, kind of like make a chain of them, a profile chain if you will, that's the tool for that. Then there's another one, profile by slope from element. So if you had a 3D line and a parallel 2D element and you wanted to project that slope or project from that 3D element on a slope to another element, you can project a profile that way. And all of these we can use this morning in this next data set. So let me bring this up. And I want to talk about the three views that we have here. I'm going to keep this snap mode here, but let's talk a little bit about the planning stages. If you look at this corridor right now, as we left off in Chapter 7, and then we applied super elevation in Chapter 8, we stopped our corridor short of the intersection, okay? And now you notice that I've already planned for this, if you will, intersection gap in here. And the way I did it in this case was with switches, okay? So my template has, if we just go back to the corridor real quick review, I'll show you this particular template has a left and a right switch. And what I'm doing is I'm saying that if the switch value is 1, then I don't want to draw the shoulder and these slopes, okay? And so if you test it and go to these values here, you'll see that if I set the value of the switch, and we went over this in the corridor in the template design, if you set that to true, in other words, if the switch value is 1, then this won't turn on. And the same thing with the right switch. If that value is actually 1, which is the distance between these 2 points, which I can control with a parametric constraint, then it turns off those intersections. And so then if you go back to the corridor, I'll show you the corridor objects for this. This is the resurfacing on US 98 corridor. If I click on this corridor and bring up the corridor objects, you'll see that in the parametric constraints I have a left switch set to 1 for a range that goes between this radius point and this radius point. And then on the right side it goes from this radius point to that radius point. And what that's essentially doing is it's giving me a gap to put in my intersection. And if we zoom in close, you'll see that there's no longer a shoulder, an unpaved shoulder, and then the tie down slope there. And there's no longer one on this side either. And then the same thing on this side. So now I've planned for putting this intersection in here. Now the next thing we need to think about is, so this corridor has to dive into this existing road, all right? And it's crowned normally according to the corridor design off of the profile. So I have a fixed profile on this edge of pavement, or a fixed line on this edge, a fixed line on that edge, and then I have a fixed basically widening edge over here, and the same thing over here, which is where this right turn lane is. So I've got to figure out how to get a profile around this radius that matches this line and this line. That's just a normal curb return or curb return profile. And then also I've got to figure out how to get from the traffic separator, which is sloped up from my profile grade line, and then have it all tie into this existing edge of pavement here. So what I want to do is I want to create a boundary, in essence a 3D boundary around this intersection, and I'm going to use the radius points as 1. And so the first thing I would do is go out here and start drawing some construction class elements. So this is the first thing you're going to do, is go out and use the line between points, and then use the construction blue lines here in this case, and then I'm going to start a point right here on my radius, and I'm going to go perpendicular to the traffic separator, so wherever that is, and that's going to define the back limits of that side. And then I've also got the same thing here, so I want to find my radius point here and go perpendicular to this traffic separator on this side, and there's the back limits there. Now I've got to, in order to close this shape, I've got to basically follow this traffic separator down and around. I'm not going to worry about the nose, because the nose we can handle a little differently. As a matter of fact, I could even delete that nose if I wanted to, but I'm not going to at this point. So I'm going to draw a different type of line, which is a single offset partial. And I'm going to select this traffic separator, and then I'm going to select the limits of the intersection of these two lines and this point right here. Let me do this over, because the line actually starts there. So I'm going to use this parallel line offset, make sure I'm doing construction line blue, and then pick this element, and then I want to set it and set the offset start point here, and then go to the intersection of these two lines here. And I can see that it's actually drawn it out there. So let me get out of this command, and you can see if I tab, I'll have a construction blue line there that I can select, and it's a zero offset. Now I'm going to do the same thing with the other side of the traffic separator here. So I'll do the same partial, single offset partial from this line, and I'm going to set the offset value to 0 and snap to this point, and then go to the intersection of these two lines. So I'm really just kind of closing in this boundary. And then I'll reset, and then I want to close it off here, so I'm going to do the same thing. I'm going to construct a line, make sure that it's blue, and then select from, and I'm going to tab till I get to the blue line there, and then do the same thing here, tab till I get to the blue line, and I could also turn off that traffic separator level if it's easier to get to, so I can turn those levels off and just snap to the point here. Okay, so now I've got this boundary around here, and I'm also going to need to put in, well, I've got the radiuses there, so those are good. Can use those as boundaries. I'm also going to limit the intersection, since I pretty much modeled it up to here on both sides. Now I just want to essentially close this off by putting in a perpendicular line to the edge of pavement, and then down along the edge of pavement, and then to the other side of the radius. So I'm going to do the same thing. I'm going to put a construction line perpendicular to this milling line, and then have it perpendicular to the milling line, and then have it snap to this radius point. Do the same thing on this corner over here. So I want to start it perpendicular to this line, and sometimes it won't do it exactly that way, so let me make sure I'm snapping to this radius point there. Okay, so now the last thing I want to do is I've got to basically build another line on this milling line here that goes across the intersection. So I can use that same single offset partial, and I'm going to locate this milling line, and then I'm going to start at an offset, which is really the intersection right here. So I want it to be 0 starting there, and then I'm going to end it at this intersection over here. So now there's actually another element there. If you tab, you see I've actually created an element that goes across that intersection, and I've now got basically the boundary of where I want my edge of my pavement transitions to go. It comes down here along there. So I have the 2D boundary. Basically what we're doing now is we're going to build the profile of this radius. So I'm going to go ahead and open the profile view for it over here. It displays in this view, but before I can do that, I need to have a profile on this line and on this line. And if you look at it, it says there's no active profile. It's in the heads up dialog that pops up about 4 lines down, no active profile. And it also tells you the same thing here, no active profile. So in order to get a profile on this line, I can use the elements in the 3D view because essentially they're following the corridor, but these are 3D lines that come from the templates that are following the 2D lines. So what we've got to do is circle back, and now that we've located it in the model, we're going to put that profile back on the element because it's really being calculated from the template. And so there's a tool over here in the vertical geometry which is called Profile by 3D Element. And if you follow your prompts here, it'll say locate the element to profile. So I'm going to locate this element right here, and then it says locate the 3D element defining the profile. And what I'm going to do is I'm going to hover over this until I see the pavement asphalt PM line in the model that represents that particular 2D line, or where that is located in the model. And then when I click on it, it will actually apply this profile to that line, okay? Because these lines are just 2D right now. But in order to get construct some 3Ds, we need to actually put profiles on them. I'm going to do the same thing to this line, and I'll zoom out and find the pavement edge on this line right here, and it will put the profile there. I'm also going to do it on these 2 edge of pavement lines. I want to get the original element here, right there, and then locate this edge of pavement line here. Okay, then I have one other here to do, which is right here, and I can get that one from the model. It would actually be this line right here. Okay. Now, once you have these profiles created for these lines, and now if you look, if I hover over them, it says active profile exists, active profile exists. Then if this was built as a fillet off of those 2 lines, then it should use, if you use this quick profile transition tool, it will actually create a profile of that element if all works properly. And sometimes it doesn't, and I've sort of planned for that. So what you can do is, and this will automatically become active even though it's in error, and it's probably because, well, I don't know, but it sometimes works real simple, but I think because of some of the trim backs and everything that's in this data set, it's not working. It's not working, let's just put it that way. So there's a backup plan for it. What you can do is just set this as this is the existing ground, just set it as active for the time being, and I'm going to show another method of doing this. And as we've worked through the training set, we've always had a problem with these transition profiles on this intersection for some reason. So I want to show you another way of creating the same thing. So now that we have there's a couple other tools here that you can use. So for example, if you want to see where this profile intersects this profile line, what you can use is another tool called Profile Intersection Point. And when you select that, it asks you for the element to show intersections. That's this line right here. And what I want to do is show me where this profile crosses that line, or actually where it intersects that line. And then I'll select this line as well, right here. So I think I reset out of that. And locate the element that intersects it there. And then locate the element for next intersection would be this tool. And what you're seeing here are these 2 balls that get drawn out here. So that's basically showing me where I need to have my profile between those 2 points. But it doesn't show me the tangent that they came off of. If you want to see that, you can actually use another tool here called Project Profile to Element. If you use this project profile element, it's going to ask you the same thing. Select element to project. Well, actually, it's a reverse. So I'm going to select this element here that has a profile on it, and I want to project it to this element. And you see now it projects that profile to that location. Obviously, there's some little issue here because those 2 points should be on there. And then I'm going to do the same thing over here. Element to project this line, and I want to project it onto this profile. And again, I get some pretty weird results here, but what I'm really trying to do is show you how you can then construct a profile from these two projections. The reason why this projects this way down here is because this line actually extends down. And it's not really clean in this one here, but let me show you. What I'm going to do next is just do a line between points, and I know that this is a valid point, and I know that this is a valid point also. All the stuff going on in between there is, I think, just the way it was, the direction in which that line was created. I can do the same thing over here. I know this is a valid point, and let's say I plotted another point over here that I knew that was a valid point. And then what I'm going to do is delete these profiles. And this one, I'm going to delete that one as well. And what I'm left with is these two tangent lines coming into these plotted points. And let's say I know that these tangents are good. And then what I can use is a vertical reverse curve transition tool, which then I just select the view and I locate the first element and tell it I don't want to be offset there, and then the back side I don't want to be offset there. I want to start at a point here and I want to end at a point right here. And what that does is it creates this reverse curve in there for me. And if you want to go change the parameters, you can, but then once you've created that profile for that curve return, you can just use the set active profile. Now, another thing that you could do is if you wanted to save this out to your GPK and then either construct a profile using the legacy tools, or you already have that profile in that element, you can import it to it, and then once you have it, you're just going to set it active. And then by setting it active, you're basically creating the 3D element that is that line. Okay, so if you think back to the slides, I said we're going to take and we're going to use the profile tools to create 3D elements from our 2D elements. So that's essentially what I did right there. Let me do the same thing over on this one. Attempt to do the same thing. I'm going to do this, display it in here, and then I'm going to repeat this procedure. I'm going to plot these points from these two lines. There's that first one. And there should be another one over there. And then the same thing, I'll use the projection tool and I'll select this profile to this line, and I get pretty close to it, and then I'll select this profile and project it onto this line, and I get some other crazy stuff going on there. But once I have, and this is, it could be just some issues with the software, but again, I'm just doing this for demonstration. You would want to validate it with your profile designs of your crossroad. And then I'll do the same thing here. And just basically place these two lines. Once I have those, I can delete these things and use the it's because it's active. I want to clear it as the active profile and delete it. Then I can use that same reverse curve transition tool, select this tangent and that tangent, and then start at this point and go to this point. And now it's created a reverse curve in there, and I'll set this as active. In this data set, this is the most difficult lines to get in 3D, just because these commands can be fickle in this data set. But now once I have these 3D line strings, I have them out there that way. You could have also used a quick line between points if you wanted to, and just drew a line from one point to the other. And if you're going through the data set and you want to do it that way, just to get a line in there, the only issue obviously is that this is the straight line and this is the reverse curve line. So you're not really truly at a tangent with you have sort of a little break here. And that may or not be an issue depending upon, you know, how much it breaks. In this case, I guess this is a 0.25% and this is 0.49, so it's a quarter percent. That may be acceptable on this job, it may not be. So there's lots of different ways of getting your curve return profiles in there, but once you have them in there, you're going to set them as active, and that sets the active line here. Now, the next thing we're going to do is we're going to get the profile for this line right here, actually these few lines right here, using the same tool, which is a quick profile from surface. So in order to get this profile up, what we're going to do is use the normal show profile tool in this view, and then there is a quick profile from surface tool in the profile tools off of the window. You won't find this in the vertical geometry tools. That only shows up in this view here, and that will eliminate you from having to pick the view, pick the begin and end point, offsets, and all that stuff. This is a quick profile from surface, and what you're going to do is you're going to identify the proposed surface. Now, this line has to cross. It can't cross multiple segments at a time, so you have to identify multiple surfaces. And the way corridors get built is they get built, a surface is a component shape. So if you think about your template, the different components you had in there, those are different surfaces. If you wanted to be able to select an entire surface, you would have to set your corridor stage to the top mesh, and then you could just pick the entire top mesh and it would basically show the profile for the whole thing. I'm lazy, I don't want to go back and reset that corridor design stage, so I'm just going to click this surface, and then if I reset, you'll see that it draws that part of the proposed surface on this profile. And then I can just basically do the same thing, quick profile from surface, and I'll select once I have to set this profile active. And this command is kind of picky too. If you're in this tool, then when you run the quick profile from surface, what you should get is a prompt that says locate the reference surface. But this profile view has to be active. So then I'm going to click on this component here. I'm going to turn off. There's actually two more surfaces because there's a little pavement section that represents where the curb would normally be, and then this is the widening part of it. So I'm going to select this surface, and then I'm going to select this surface, and then I come back to this view and I hit reset, and it will plot the remaining two lines. So it takes a little practice getting this tool to work the way you want. Once you have it, then you can do a complex by element, and you can select this line and have it go automatic and accept it. And once you have it, then you just set it as the active profile, and now that line is also drawn out there. Now the easiest way to see some of these lines is to go to your Project Explorer, and I just hit the F11 key, and you can go to the Civil Standards, and in the Civil Standards, for all the features drawn in this file, they're in 3 organized folders, and that's kind of the way we set the workspace up. So anything that's a template component is going to be in a corridor components folder. So I can uncheck all those features, and here's all of the components in our templates. I can uncheck those just like that. And then anything that's a 3D line, I can uncheck that as well. And so you see I've got these 3D lines out here now. And then if I turn on the, I believe it's the default level, this might be the construction lines level. in this view. So I turn those back on. You're going to see now there's this blue line that got created. Okay, so that is by basically draping this to the surface and then setting that as the active, I get that profile line. So I'm going to move this over here for now and do the same thing on this one as well. So I'm going to have to turn on, just forgive me, I'm going to turn these shapes back on, and then I have to turn the construction elements back off. So in order to get this line over here, I'm going to use the same tool, and I'll go to the profile for this line, select this view, make sure this profile view is active, go to the quick profile from surface tool, locate the reference surface. So I want to pick the first surface on that side of the traffic separator, that'd be this piece, and then this piece, and then if I reset in this view, you'll see now I have this profile, and then I'll go ahead and use the same profile complex by elements, and I'll select this first element here, and it will go all the way across there. And then if I select this and make it active, I'm going to have another 3D line out there. And if I turn on the construction class elements and turn off the corridor components, you'll see now there's that line. So there's the new line for that one and the line for that one. Now I'm going to continue on and do these same lines down here the same way. So I'm going to select the profile here, open this up, make sure this view is active, go to quick profile from surface, and now I'm going to select on my US 98 widening here, I'm going to select this surface and reset, and now I have that. And if I select this line, I basically set that active. And then I'll go to the other side, find the profile for this. And then this is going to be this little widening segment here. So I'll quick profile from surface from this pavement widening, and it will also tell you that it's a pavement asphalt PX. And then reset. And so you do have a way to verify which shape is which if you kind of get lost in what's in 3D and what's basically, which shape is which. And now once that's set active, then if I go ahead and turn off these corridor components again, there's the new line there, and there's a new line over here. And then I'm going to come back and get these traffic separators in a second, but what I'm also going to do is find this line here and go to its profile, select this view. Now in this case, what I'm going to use is the existing ground because I have to tie to this milling line. So that milling line is right at the existing ground, so I'm just going to select this and choose set active. Okay, if that was a proposed line that you were off of another template, and now you actually have another line out here, right there, that connects between, actually not that one, it's this one right here, that connects these two lines there. The whole purpose for this is that eventually we're going to select them all and make a terrain out of them. So what we've got to do next is just go find these traffic separators, and I'm going to turn on the traffic separator level over here in this view, and make sure this is active. Okay, where'd my traffic separators go? Oh. I could also use the profile from surface tool on this one, but I was going to show the profile project. I don't know why that. What am I missing here? I didn't delete them. Somehow I lost the traffic separator level in this view. I don't know where they went. But I do have the two lines. Let me see if I can use the profile. I can project by a range, a profile to element, or actually just use this profile by 3D element. So I'm going to select the element to profile will be this line, and then the 3D element defining it is going to be this traffic separator line right here. And then if I open this view up, I should have profile for this one here. And this is what happens sometimes with the project. But then if I can either use a line between points here and just snap to what it was trying to construct here and go to the very end. And it looks like I missed it by a hair. I'll try to snap it to this point right there. And then I'm going to select this line and make it active. And that will give me the 3D element out there for that line. And I'll do the same thing with this one. So if I view in here, turn off these canopies, what I call canopies, go to the profile view for this one, use the profile by 3D element and select the element to profile would be this line, and then I want to use this traffic separator, and it draws that line in there again, and then I can just make a clean profile with a line between points and snap. Wait for my rubber banding here. Then I select this line, make sure it's not the other one, and set this as active. Okay, and if I turn off the corridor components and turn it back on in this view, the construction elements, turn off these 3D lines, you see now I have these traffic separator lines as well. And they tie into, well, they should be tying into these two. That one's pretty close. I'm going through this fast, so some of these you may have to do once or twice in order to get them to work properly. But the next thing you do in the exercise is to get the profile for this one right here. And in order to get this one, you can just use the profile intersect points. So you select this profile window and use the profile intersect points, and you say I want to show on this profile where this line intersects it, and it should have plotted a point, and where this line intersects it, and it will plot the other point. And then you have the 2 points that you can construct a line in between. So again, I'll just use a line between points here. And when you get all said and done, that basically will be the last one. And this is, like I said, this is the work involved in getting the boundary for that intersection. Once you have those lines, the rest of it is really easy. Next thing we're going to do is go in and select. We're going to select using a selection set. I'm going to add each of these boundary elements to my selection set. Obviously that one didn't hit. That one, that one, that one. I can't guarantee I'm going to get a real clean terrain here, but this is essentially the steps involved. Once you have the boundary of each of those created from their profiles, then you go to the terrain elements, create from elements. And if you use the DTM proposed, it will be in a construction class, and we're going to use these as boundary lines, and then go ahead and ask it to data point to add the selected elements, use boundaries, edge method none, And what it will do is it'll create the surface which warps from a normal, the normal cross slope on each of these roadways, follows down along that traffic separator. If you needed to modify that traffic separator profile, you could. It also runs around these radiuses, and it ties into this existing edge of pavement. And that's essentially how you would build the terrain part of it. Once you have the terrain, then you can apply, in the 3D geometry tools, you can apply a surface template to it. And if you look in the DOT template library, in this case I've copied one over, there's a pavement asphalt template that looks like this, and it has a depth and with a label for the base and for the normal structural course and friction course. So I'm just going to choose OK. It asks to locate the terrain. I wasn't careful when I created that name, so if I want to go back and add a name to that intersection terrain, I can. And then essentially I'm going to use the surface template. And if I turn on my corridor components now and rotate around, you'll see that this intersection now has a pavement depth and a base. And you can see how it's diving through this State Road 61 corridor, and it's actually matching in here to where the edge of pavement is for the widening of this other one. So everything matches according to the way we built the boundary of the templates. Now, the next thing you would do is, in order to complete this intersection, we need to put in some type of a linear template around this edge. Now, the work is pretty much done, because in order to place a linear template, you just have to have a line and a profile. And so the profile we created in that little exercise for creating this curve return profile. So what I'll do next is just apply a linear template. And I want to kind of look at what I need here. It looks like I need a curb with a sidewalk right up against the back of the curb, and then some type of tie-down slope. So I'm going to go to my linear templates, and it says locate the element, and then it wants to know which template are you going to use. So I'm going to go to my linear templates, and I'm going to find the shoulder, and there is a curb. So it doesn't look like I have the one that I need yet. Let me look and see. That's just a normal sidewalk. So what I would probably have to do would be to go in and actually modify this this template a little bit. So let me do that. So I'm going to go into the template library here, and I'm going to go to this curb type F. And what I like to do is copy these if I'm going to make a modification to them, and then paste it right back on top of itself. And then this is going to be renamed. I'm going to take this outside lane right off. So it's just going to be a type curb F, maybe with sidewalk or something like that. And what I'll do is I'll just delete the pavement part of it. And then I'm going to reset this as the origin by using a right click and doing change template origin. And then I've got to move this up to the back of the curb. So I'll set this value to 0. And then I've also got to put in some tie-down slopes. So I'm going to go over to my end conditions folder, and I'm going to go to my parts, and I'm going to put in a fill slope. That's a 1-to-1. I don't need that. I'll try to 2-to-1 fill, and pop that there, and then put a 2-to-1 cut this way. And so now, as long as these are going infinite, which they are, I can tell by just hovering over it, then I can apply this template. The other thing I want to do is make sure this has a slope on it. When I deleted the pavement, it tried to match the slope of the pavement. So in this case, I'm going to go ahead and use that slope for now. And then I'm going to close and save this. And it looks like I edited the wrong one. No one's ever done that before, have you? So the one that I really want to use is the opposite one, the original one. So that would be this one right here instead of this one. Choose OK. And then I'm going to locate the element It looks like it reset out of it. I want to use that template. I want to start at the beginning and go to the end, and then it gives you the option which side of the line do you want to put it on, and then the exterior angle. And I'm not sure why I don't have the curb and the sidewalk came in. I don't understand. Maybe I don't have that active terrain set or something. Should have tried to tie but I think this is active. Let me get out of this tool here. So I would have to do a little, maybe it did go to the ground. I guess it's right close to it. So at any rate, now that you have this linear template here, now you can start applying some clipping, corridor clippings. So this one is going to come right up to here. Now in this case, because of the template gap, it didn't put the shoulder right up to the curb. But obviously I need to clip out this State Road 61 corridor, so I'll show you those tools. Those are going to be in the corridor tools, and you'll see there's these scissors here, so you can add a clipping reference. So I'm going to select the corridor to be clipped. That will be the State Road 61 corridor. And then locate the first clipping reference. So what I want to try to do here, if I turn off these corridor components, I should be able to see this terrain. So there's my terrain. That's going to be one clipping reference. And then I'm going to reset because I want to show you how it processes with just this terrain clipping. And then I'll come back in and use the linear template as another clipping reference. I use the Project Explorer and I use it for just about everything. Like in order to pick that terrain, I came over here and I just turned off these components because I know that if I turn them off, I can see my terrain. My terrain is also on a construction class element, so I can use the F7 key to turn it on and off if it gets in my way. But now what you're going to see is how it's clipped the State Road 7 corridor according to the boundary. And if you looked at a top view, you would see these two lines are right on top of one another. The other thing I want to do is clip this corridor with my linear template as well. So I'm going to go back to the corridor clipping, and I'll select the corridor to be clipped as this one right here, and then I'm going to pick the boundary of the linear template as the clipping reference and reset. And now the corridor will reprocess again, and it will clip out what was the sidewalk and buffer slope, curb, sidewalk, and buffer slope, and then it should fit in there that way. If I go to the top view, you'll see that now these things all tie together this way, and this is where I had that little gap. So I built one corner of the intersection here. Now I know we're short on time, so I'm going to try to answer some of the questions, and I'll also open up a final view of this whole thing here, which is also in the data set, in the Chapter 10 zip data set. Basically this intersection is already built. It takes a little practice, I will say that. Every intersection is different, and that's why learning to use these tools is going to be beneficial for, if we go back to this slide here while this is loading, you'll see that this method can be used for building each and every one of these sort of details here. And then once you've built them a few times, for things like traffic separator noses, once you place that vertical profile in there and apply the linear template, you're really going to have the same situation over and over. So this is ideal for a civil cell. And as a matter of fact, we're going to go over civil cells in the next one. We actually have a civil cell that will do that. As long as you have a profile associated with these two traffic separator lines, then all you've got to do is pick these as reference lines, and it will draw in this traffic separator nose. And notice this is off of a skew. So it's basically trying to determine what the profile is between these 2 points on this radius, and then it runs a linear template, finds out what the middle point is between these two grades here, and it will actually intersect the middle there. I mean, that's one example of a 3D civil cell. Median crossovers is another one where you might have a curb return at a bullet, sort of at a median crossover, mitered end sections, retention ponds. A lot of these things all can be detailed out with civil cells. The intersections are really the ones that there's no two intersections alike, unless it's just a normal rural type intersection, in which case we actually do have a 3D civil cell for that as well. So let me try to get to some of these questions here. Are all these profiles from the proposed components intelligent? The future changes are made to the main line. Yes. In other words, will the changes to the main line side road vertical affect the intersection? Yes. That's a very good question, and that's because of the way we're actually building these. Anything that gets created off of a surface and then the surface changes, obviously the profiles are going to change as well. So yes, they are all ruled together, which is why it makes some of this stuff very tedious, and sometimes it doesn't always work. The first time it may be just a break in the rule. But yes, if I were to go in and change the, say, slope of this template, actually this template right here, and that would modify this slope along here, it would modify possibly what the intersection point is here of this radius return, and all of that should roll through the design of the intersection if it's all built together. Are there any additional options for training classes besides the posted data set? The webinars can be intimidating if not familiar with the process. Well, we do our best. I mean, we documented a process. We actually have pictures and step-by-step guidelines for a particular data set. The idea is to get the concept down and try to work it through and learn the tools and kind of have an end goal in mind. If you want to try a simpler intersection, you can use this data set and go in and try to use these same tools on a different intersection. I think that curb transition tool is the quick profile transition tool is a little more forgiving in these intersections here. But the main thing is to just practice using them, see what they create, see what you get, and just don't be afraid of them. As far as any other classes, we have some district classes that are going on. We also provide classes, albeit sort of condensed classes at the design conference and also the FLUG. We also provide phone support on a daily basis for anyone calling in and having any questions on how to use some of these tools. It's going to be a learning curve at first. We just need to share our knowledge and ask questions when you get stuck. If something isn't working right, let's just try to troubleshoot it and see where the issue might be. We can both learn from it. In the future, or in another intersection, I'm going to cover some other things, the 3D civil cells that we have and how you can apply them, build them. Here's an example of how to apply this traffic separator. How would you build this island in here? We can go over some of these techniques. We do have some curb ramps too that we've created, 3D civil cell curb ramps. We have some techniques for transitioning from a normal straight up type F to a drop curb. How you can actually use some of the transitioning tools for doing some of that modeling. And I don't think it's this file, but we created a little webinar on creating a retention pond with these same type of tools. But if I can reiterate, basically the workflow is you build 3D lines from these profile tools and also your corridor. Your corridor has 3D lines in them. And then you create terrains from the elements based on boundaries, apply surface templates, and apply linear templates. And if you can, then use the clipping as necessary. And that's basically the detail modeling steps. A couple more questions came in here. Do you know what the FDOT requirements for as deliverable will be in this 3D? Basically, the deliverable is going to be a model. We've come out in the CAD manuals defining what the specifics are. Next week, this is a good segue. We'll be covering how to create the 3D deliverables in accordance with the current CAD manual that was just published. Hopefully you all can come on there. Can an intersection plateau be done? Of course. If you know how you want to design it, you can basically add in control lines in there and plateau the terrain accordingly. We'll go ahead and record this webinar and have it posted in the next day or two. I'll document the questions and the responses, and that will get posted along with this PowerPoint that was created for this. They'll all be posted. I think that pretty much used up the hour here, so thank you for attending. I look forward to seeing you guys on the next webinar.